Hi there, everyone. So I wanted to go over part 4 of developing ideas here. So the goal here is to, as it says right here, develop accurate and detailed planning, drawings, or diagrams, and outline the requirements for the creation of the chosen solution. So you should have chosen a solution by now, one of your sketches. This is, like it says down here, this is where you may tweak your chosen design idea, make it real. You might do things like change sizes, work out specific details, etc. Everyone had a different degree of details when they made their sketches from earlier on. So some people are going to have more work to do now, others less. It's going to be different for everybody. So what I've got here that I'll go through a bit are I've got some tips for actually modifying your design. And then down here, I've also got some tips on how to create accurate and detailed drawing diagrams. So there's kind of two things to think about here. There's the design itself, but then there's also like how you're representing it. And those two things are really tied together. So if you just kind of stick with me here and think about what I'm saying and think about how it applies to your design, I think that's probably the best approach here. So I'm going to go through some of these bullet points for anybody who finds it intimidating to read them. And I think that'll help. So looking ahead here, we see that we do need to get our toy to fit into a certain volume. What that really means is we should try to stick to some different sizes here. And I give you examples, and a lot of you have been looking at these already. These are like a height, width, and depth. If you want more details on that, you can look at the part 2 video. Or just talk to me about your design and we could figure that stuff out. We also want to make sure that your design can actually be 3D printed. For the most part, this won't really be an issue for a lot of you. If you try to incorporate some of the details here, I'll let you read them yourself. That would be helpful. But things, you probably don't have to worry a ton about these first 2 bullets right now. Those are things we can figure out later, but I do want to highlight that we want to avoid tiny details. So really, really intricate or tiny designs or letters, those are things that do not usually come out clearly. So try to keep things a little bigger. And the other big thing here has to do with the walls. So this is something like, say you're making a maze toy. This is just, like a super simple maze, and you were going to have walls like this that are in there, and they're going to fill out the space, and maybe a ball is going to roll around inside there or something like that. We had walls on the outside. The thickness of the walls, the distance from one side to the other, is really important, all right? Usually 3 millimeters is a good thickness to keep a wall from snapping off. So like if you were to have a box, and this is the wall of the box, let's say, what I'm saying is that the thickness of that wall, we'd see the back of the box. This is all sliced open. This is called a section view. The thickness of this wall should be about 3 millimeters. If you're making this wall have a thickness that is too big, that is like 5 millimeters, and it's like coming way out to here, that's probably too thick of a wall. It probably doesn't need to be a whole 5 millimeters. So that's all I'm getting at here is thicknesses of walls can be like 3 to 5 millimeters. If the wall gets taller, though, you may need to make it thicker, or it's more likely to snap off. If somebody were to push on it with a finger, it's more likely to snap off. So that's really all this stuff is talking about. Okay, so keep that stuff in mind. We just don't want paper-thin walls. Moving on down here, if you have multiple parts and they have to fit together, you really want to make sure that they do fit together. And I've already talked to a lot of people about this, but some people may need to figure that out. Big situations where that comes up is if you're doing some kind of a toy like a shape sorter, where you are going to have shapes that have to correspond to and fit into openings. You really want to make sure that the distance between this edge, let's say, this edge and this edge, when you actually go to slide that piece in there, you want to make sure that you leave enough of a gap. So you want to make sure that you're we call it engineering a distance in there. There should be space between those two things. And I'll do an example of something like that down below when I get to this stuff about drawing. So that's actually a great segue here into talking about the drawings and diagrams. So my suggestion here is that if possible, you try to draw full scale. What that means is that if you are going to make your toy, let's say 50 millimeters by 25 millimeters, wow, I can't, 25 millimeters, there we go. You should get a ruler and you should actually draw a line that is 50 millimeters long and then draw another line that is about 25 millimeters long. And I don't even think I drew this to the scale because I didn't measure it. But that way you're going to really see what is the true size of my toy. You're going to be able to see it on a piece of paper and you're going to be like, yeah, that looks about right. And the opposite of that also is if you draw a shape and you're like, wow, I drew this square and that's going to be a shape that's going to go fit into something and I think this looks good, you can grab yourself a ruler. Here is a ruler that I'm drawing, okay? And you can grab yourself a ruler and you can hold it right up to that and you can measure and say, you know, wow, from here to here, let's say, is actually, you know, it's 25 millimeters. So you can actually measure this if you're drawing in full scale. So that's one big thing to think about that I would really suggest is actually use a ruler, actually use other things. You don't have to worry about T-squares or triangles unless you want them. I have them in the classroom. Another big thing here is that you want to try to include all of the views necessary. So what the heck does that mean? So imagine that we have, let's say, a house, all right? A pretty typical house. You know what? I'm going to make this house a little longer. So we have a house like this, and it's got a roof on it, and I'm going to keep it really simple. It's got a door on the front, and it's got windows on the side. And obviously, your toy will be a lot more detailed than this, but this is just my simple example. If you think about it, there are a couple different views that we can view this house from. All right, we could look at it from standing in front of it. If we're a person standing in front of this, that would be what we call a front view. We can look at this from the side view if we were a person standing over here. Okay, this is a side view, and we'd be looking at sort of this surface right here. Okay, and I'm going to get rid of those for now. The front view there was looking at this surface. Okay, and then we could even be in like a helicopter overhead. Okay, this is my helicopter. All right, and we could be looking down on the top of that. And we're going to see this roof, and we'd actually probably see the side of the roof that's facing away from us right now. And what's cool is if we draw all those views, so let me actually do that. I will start with the front view, and I'll do it in green over here. So if we were to draw the front view of this house, we would see something like this. We would see that door right there. Okay, but we wouldn't see any of the other sides. We'd see it as if we were looking at it perfectly straight on. We would just see all of these edges right there. Whoops. We'd see all of these edges because those are all that's visible. We wouldn't see the back edge. We wouldn't see anything else. Then we could draw a top view, all right? And I'm just going to erase this to help us out a little. Our top view is going to be where we're seeing all of these surfaces up here. And if you think about it, the edges of this are going to line right up with the edges that already exist. And we would even see this edge right here. We would see that up top there. Let me go like this. There we go. And that is what our top view would look like. So we have our front view, we have our top view, and we have our side view over here. If I draw that, everything is going to line up. So this edge is going to have a line, this edge, and we would see the front of the house, the back of the house. We see the top of the roof here, and we see the edge of the roof where like the gutters would be. We see the ground line, and we would see these windows, which were actually invisible before when we just drew the front view. Now we can actually see where these windows are. So this helps us out a lot. Well, let me label that side view, okay? Because now we can actually dimension all of these, and I'll just use a different color. And that's the idea behind these accurate and detailed drawing diagrams, is we want to actually show and be able to dimension how tall all these things are. So we could say, oh, the height of our first floor is about 10 feet, and then our roof goes up another 8 feet or something like that. We'll put that over there. From there to there is 8 feet, okay? And the overall height of the house now is 18 feet. And we can keep going like this. We can put the overall width of the house. We hopefully wouldn't do it on top of these words. Maybe the house is 25 feet wide, and then it's a little deeper than that. So let me get rid of that. We can know that the depth of it from the front to the back, is, let's see, 40 feet or something like that. And so that's the idea here behind these front, top, and right side views, is we can start to see all those sizes. And we can even see different things. I got to fix my door. It's driving me nuts. It wasn't the right height. There we go. We can even see things like details like how tall is the door? How tall is it from the bottom to the top? Maybe that is 6 feet or something like that. And then these windows are, let's say they're 3 feet from the ground, and they are, they're 3 foot tall windows. And we can even put the width on here. So showing the top, front, and right, the top, front, and right side views of an object allows us to show a lot more details of it. So that's really what we mean here when we say we want to include all views necessary. And I mentioned the front, top, and side views. Other things to think about are what are called section views. So that would be like, what does a part look like if it is sliced open? And so a good example of that is, let's say that you had a toy where you wanted to have like a peg or a bolt, okay? And it is sitting inside of a hole, okay? So maybe instead of showing that peg or bolt on top here, we've got it floating up in space here, and that is like the peg, and there's a hole for it, and this is going to go down inside there. Well, we need to know, like, what does this look like when it's sitting inside there? We can slice this part open, and so we might slice it along that line. We might show, let's say, a top view, as if we're that helicopter before flying up here. This is my helicopter. We're looking down. We might see a top view where we see the circle for, and you would make sure that your lines are nice and straight. I'm just doing this quick for the sake of the demo. We could slice this open right along here. That's the way we do it. And we could be looking in this direction. And now we might see, instead of just seeing this plane like this, or maybe even seeing the sides of the hole with dashed lines, we could see as if this were sliced open here, okay? And now we can even start to draw in and say, okay, there is the bolt, right? That's the bolt that we want to have there. And this is what it looks like on the inside. Let me just fill that back in because I erased it. And now we can start to add those dimensions like I had a second ago, where we can say this gap from here to here is one of these sizes up here. Maybe it's 0.508 millimeters for that gap. And that would give us a nice loose fit, so this bolt can wiggle around inside of there and can easily be pulled in and out without scraping. These are the kinds of details and dimensions that we are looking for. All right, so I'm going to erase that now. But that was called a section view or a cross-section view. Section view, cross-section, what the part looks like sliced open. So it shows what stuff looks like on the inside. Other things to think about. So overall dimensions, so I already talked about height, width, depth, but where are holes? So if you had something like this, maybe it's a threading toy where you're going to have the user, there's lots of holes, maybe they're in the shape of a smiley face, okay? What we need to know is, where is the center of every one of these holes? How far is it from an edge? Because in Onshape, you need to be able, I'll use a green color now for dimensions, you need to be able to say, how far is this from the top of that object? Okay, how far is this hole from the top of that object? What's that distance? And so this allows you to start figuring things out, and it sort of gives you like the option to do an X and a Y. So like the X distance, how far is it from here to here? How far is it from here to here? And then how far is it down? So you can start to think about that stuff when you do these final drawings, and you make sure that you show where the centers of holes are. Also, how big are they? How big is this hole? What is the distance across, or the diameter, that's a diameter symbol, of that hole? Okay, and this lets you really start to think about the sizing. If we look at this and I were to tell you that the overall size of this, let's say, was 50 millimeters, I'm just going to put 50. You better not tell me that the diameter of this hole is 60 millimeters, because that would mean that that hole is bigger than the entire object, right? So we need to make sure that the sizing is about right here on these things. So if the way I drew this is 50 millimeters, maybe the diameter of that hole is really like 10 millimeters. And that should mean I could fit at least 5 of these holes, because 5 times 10 would equal 50 across here. And that also lets me figure out these sizes. You better not tell me that the center of that hole is 60 millimeters from that edge, because otherwise it would be down here. That hole would be like off of the 50 millimeter opening. So it's a little bit of math, but it's like applied math. It's like real math. You're really trying to figure stuff out. Maybe that hole is 30 millimeters from the top, and this one is like 15 millimeters from the top, and it's 15 millimeters from the right side. So you can start to label those, and you can start to put all those on there. And that way, when you get into Onshape, you'll just be able to type in the dimensions. It'll be super easy. So you could think about how things are rounded, how things fit together, which I just talked about, the clearance gap up there. And finally, you want to be thinking about what are any other things, assembly notes, materials. How are you going to assemble this thing? Do you have to glue anything together? If you're doing a maze toy, and you've got a maze, and you've got a lovely set of walls inside here that they're going to roll the ball around. Maybe it's not quite a maze. It's just like a thing where you have to get the ball from one side to the other, and you've got a wall around the outside of it. You better show that this was like a top view, like the helicopter. You better show that as if it's sitting on a table from a front view, and you better tell me that there is a little piece of acrylic or plastic over that, and you could write plastic, right? Or else that ball, and this is maybe the ball, is going to roll out of this. If I flip it over, the ball is just going to fall on the floor. Okay, and that's no good. So you need to make sure you're including all of the notes about all of the details that you need to include in this. And so examples of that include, glue. Are you going to need to glue things together? Do you have to tie a string through something? If you have to put a string, is there going to be a hole maybe on the corner of an object that the string can go through? And you don't have to be an artist to show string. You can just do something like this and then have a label that says string, and we will know what you mean. Okay? Are there strings? Do you need little metal balls to roll around inside of this? Are you going to paint it? You can use different colors, whether you've got colored pencils. Maybe I want this to be red, and I wanted, blue string or something like that. Are there going to be spots where magnets need to go? If you're going to have a magnet in an object, like if you need 2 objects that are square to stick together, you better show me, maybe with one of those section views I was talking about before, what does the little pocket look like that the magnet is going to go inside of? So maybe this is the magnet. And you need to show me what size that hole is so that we can make sure you actually include it in your Onshape drawing. So a lot of you have already figured out these details. I just want to make sure that everybody is really thinking about them. And that is really the overarching goal of part 4 here, where you are going to come up with an accurate, detailed planning drawing. All right. And there's a spot here on the next page where you can put your record. I call it a record because you're kind of recording it. But this is just like uploading pictures of your sketches. You're just going to make sure that you have a nice, pretty drawing in there that looks really good. And you make sure you also tell me anything else that you need. So I hope this video helps. I know it's a bit long. Hopefully it helps you, and I will try to put some labels in it. So good luck on this, people.